In this video, we'll be learning about the activity series. So you may recall earlier in this course learning about reactivity, and reactivity is highest in the top right corner for nonmetals and the bottom left corner for metals. So francium would be the most reactive metal and fluorine the most reactive nonmetal. And we could relate those to things like the fact that francium has a very low ionization energy and that fluorine has a very high electronegativity. And all this is true. But I do want to point out that there's a little bit of a difference between activity and reactivity. Reactivity will tell you more about how vigorous a reaction will be. It's based on kinetics and the rate of reaction. Activity is more of something that can be used to predict whether an element will react with an ion, and that's based on thermodynamics, basically what is more stable. And so as we look at the activity series of metals, we can see that the most active metal is actually lithium, which is up here, and then rubidium, which is lower, and then potassium, which is a little bit higher. And we start realizing that, you can't simply look to some corner to predict whether an element will be more active than another. But we do have the activity series here just so that it's easy to kind of see what the most active elements are. And also it's worth noting that as metals have an activity series, there's also an activity series for nonmetals. And if we just look over here, I've got a couple examples of reactions. So if we threw a piece of potassium into water, you would get a very vigorous reaction, and it would happen. If you were to throw something else into water, like, for example, zinc, you wouldn't see a vigorous reaction. In fact, you would very, very, very slowly see some reaction. But to get any reasonable rate of reaction, you need to throw zinc into, say, hydrochloric acid, which is what we're seeing here. And instead of an explosion, you get some bubbling. You may be aware that gold and platinum jewelry do not need to be polished ever. And the reason for that is that they are less active than hydrogen. So you could even throw them into acids and you would see no reaction, causing the gold or the platinum to oxidize. So to what activity truly means. It means that if you were to take some barium and beryllium oxide, you would get a reaction to occur if you mix them together and force them to react. But if you took beryllium and mixed it with barium oxide, it would not result in a reaction. And the way that we can tell this is we look at the fact that, okay, barium is a metal. Is it more or less active than beryllium? We're making the comparison between these. And I look up here, I see barium here, and I see beryllium down here. So barium is more active than beryllium. So barium will be able to displace the beryllium because barium is more active. And on the other hand, beryllium being less active, it is unable to displace the barium. It's unable to undergo this reaction. And you might ask why. Well, you look it up on the activity series and you have that memorized, great. But the real why, the real explanation for this is that barium in the positive 2 state is more stable than beryllium in the positive 2 state. The only difference, if I look here, I've got barium is originally neutral, it's the element. Beryllium is positive 2 and oxygen is negative 2 in this compound beryllium oxide. If this reaction occurs, the products are where barium is positive 2, oxygen is negative 2, and beryllium is neutral. So the oxygen is the same in both cases. I'm really asking myself, if I've got a positive beryllium and a neutral barium versus a positive barium and a neutral beryllium, which is more stable? The answer is the positive barium and neutral beryllium. And that's predicted by the activity series. Another way of looking at this is that the electrons are more attracted to beryllium's nucleus than barium's, and that's why in truth, what's going on is the barium is transferring its 2 electrons to the beryllium, and that's why beryllium goes from +2 to neutral, as it has gained the 2 electrons from the barium, which has lost the 2 and become +2. So let's say that we've got a problem and we're asked, strontium metal is added to a solution of zinc chloride. Will a chemical reaction occur, and how do you know? Well, we have to look at the activity series. And I look here, I see strontium and I see zinc. I'm comparing the metal strontium, this is a metal, and the metal zinc. And strontium is more active than zinc, so I know the reaction will occur because SR is more active than Zn. And now I've got to write a balanced chemical equation. So what I'll do is I'll take Sr, strontium metal, and I will react it with zinc chloride. So zinc is with chlorine. I know that zinc has to be +2. I know that chlorine is -1, so it's ZnCl2. And all I have to do is say that the strontium is replacing the zinc. So I end up with a strontium being in the compound with the chlorine. I've got to be careful with this. I know that strontium is a group 2 metal, so it will also be +2. The chlorine is still minus, and so it's going to be SrCl2 as my compound, and Zn will be neutral. This is just an element, it is neutral, and there is our chemical equation. It is balanced with a 1 to 1 to 1 to 1. So this reaction does occur. Next, we're going to consider the possibility of anionic single replacement, where we have a nonmetal chlorine that may or may not displace the nonmetal fluorine in zinc fluoride. And as I look to the activity series, I see that fluorine is more active than chlorine, and so a reaction will not occur. So no, a chemical reaction will not occur because Cl is less active than F. So what we can say is that the fluorine, being negative already in the case of ZnF2, that would be the formula for this, because F is -1 and Zn is +2. That fluorine is super electronegative. It's super stable, having gained that extra electron. And the chlorine, yes, it would like to pick up an electron, but it will not be able to get it from the fluoride because it just isn't strong enough in pulling the electron away from the fluorine. So we would say that no chemical reaction occurs, and so there is no chemical equation. So all we would just say is that no reaction occurs. Hope this video has helped. Feel free to leave any questions or comments in the comment section below. Thanks for watching.